Friends, today's topic is reactions of amines. The first reaction is basicity, which is also called as the salt formation. Here the amines are reacted with acid. For example, let's look at this general reaction. The amine RNH2 is reacted with acid like HX. The X means the halogen like fluorine, chlorine, bromine and iodine. So this reaction gives the formation of the corresponding salt. Here you can see that the proton of the acid migrated over the amino group to seek the lone pair of electrons. And as the lone pair of electrons are shared by nitrogen, so this will acquire the positive charge. And with this positively charged species, the halide ion is remain in the ionic bond to give the salt. Let's see the first example. Methenamine on reaction with hydrochloric acid gives formation of this salt, which is called as methane aminium chloride. Likewise, aniline on reaction with hydrochloric acid gives formation of anilinium chloride. Both are the salts where the positive charge is on the nitrogen. Let's go for the next reaction, which is called as the alkylation reaction. Alkylation simply means the attachment of the alkyl group on the nitrogen. Here, let's take the example of aniline. Aniline on reaction with alkyl halide like methyl chloride liberate a molecule of hydrochloric acid, and the alkyl group, the methyl group, is attached onto the nitrogen to give N-methyl aniline. This N-methyl aniline on subsequent reaction with methyl chloride loses one more molecule of HCl, and it gives formation of N-N-dimethyl aniline. Dear students, this compound then again react with a next molecule of methyl chloride, and the product obtained is N-N-N-trimethyl anilinium chloride. Here, the positive charge is on the nitrogen because nitrogen shared its pair of electron with the methyl cation. So this is the alkylation of amines. The next reaction is called as the acylation reaction. Like alkylation, acylation simply means the attachment of the acyl group, that is the RCO group. Let's take the example. Methenamine, that is CH3NH2, on reaction with acetyl chloride liberate a molecule of HCl in presence of a base like sodium hydroxide. This acyl group, CH3CO group, is then attached onto the nitrogen of this amine to form N-methyl acetamide. Likewise, aromatic compound like aniline react with benzoyl chloride, whereby acylation reaction takes place by the attack of this amino group onto this carbonyl carbon. There is once again the release of HCl molecule, and the reaction takes place in presence of sodium hydroxide to give the product benzanilide. Dear students, both reactions are the examples of nucleophilic acyl substitution reaction. In continuation to the acylation reaction, let's see some more examples. For example, a secondary amine like N-methyl aniline react with acetyl chloride to release a molecule of HCl. Once again, the reaction takes place in presence of sodium hydroxide. This H and this Cl will be liberated as HCl, and the product obtained is N-methyl N-phenyl acetamide. Likewise, if we try to react a tertiary amine with the acetyl chloride, there is no reaction at all because there is no chance of liberation of H and Cl, as the tertiary amine does not contain any proton. Let's take the second example. Aniline on reaction with benzene sulfonyl chloride liberate out a molecule of HCl to form N-phenyl benzene sulfonamide. Once again, the reaction is the nucleophilic substitution reaction. Here, the amino group attack on the sulfonyl group to substitute the chlorine from here. Let's take one more example. A secondary amine like N-methyl aniline react with benzene sulfonyl chloride to give N-methyl N-phenyl benzene sulfonamide. Dear students, generally the acylation reaction takes place by use of acylating agent like acetic anhydride. For example, orthotoluene react with acetic anhydride, whereby this amino group attack on this carbonyl carbon to bring about the nucleophilic acyl substitution reaction. The product obtained is Ac2-orthotoluene with release of a acetic acid molecule. The reaction takes place in presence of sodium acetate. Next important reaction is carbilamine reaction. Dear student, this reaction is used to distinguish the primary amines with the secondary and the tertiary amines. Generally, this reaction is given only by the primary amine. Let's take the example. Methenamine on reaction with chloroform in presence of potassium hydroxide gives formation of methyl isocyanate, which is a foul smelling compound. Likewise, a primary aromatic compound like aniline react with chloroform in presence of potassium hydroxide to form phenyl isocyanate. Dear students, the secondary and the tertiary amines does not give this carbilamine reaction. Let's go for the next reaction, a very familiar one, that is the diazotization reaction. This diazotization reaction can be given invariably by the aliphatic and the aromatic amines. For example, when aliphatic amine is react with sodium nitrite in presence of hydrochloric acid, it liberates out nitrous acid, that is HONO. This nitrous acid then react with methenamine to form methane diazonium chloride, which is being unstable, easily react with the water molecule to liberate out nitrogen gas and HCl, and it gives formation of methanol. So dear student, this is one of the preparation of alcohol from amines. This reaction is largely given by the primary aromatic amines like aniline. Aniline on reaction with sodium nitrite and HCl gives formation of benzene diazonium chloride. Once again, the chemical compound involved in this transformation is the nitrous acid, that is HONO, which is not isolated but is obtained in situ, that is during the reaction. The next reaction is the nitration reaction, which is the example of the electrophilic aromatic substitution reaction. That means the reaction takes place on the aromatic ring with which amino group is attached. For example, aniline on reaction with nitric acid in presence of sulfuric acid at about 25 degrees centigrade gives a mixture of compounds like para-nitroaniline, orthonitroaniline and meta-nitroaniline. Dear student, the major product obtained here is the para-nitroaniline. We obtained orthonitroaniline to a very little extent, but in major amount we will obtain the meta-nitroaniline also. To obtain a single substituted nitro compound, the aniline gets converted to the corresponding amide by reacting it with the acetyl chloride. Aniline on reaction with acetyl chloride gets converted to acetanilide. This acetanilide on reaction with nitric acid and sulfuric acid gets converted to para-nitroacetanilide, which on hydrolysis gives formation of para-nitroaniline. So if we desire to obtain a single compound like orthonitroaniline or para-nitroaniline, this reaction will help in isolating the single isomer. The next reaction is bromination reaction. As the name indicates, the bromination simply means the attachment of bromine atoms on the aromatic ring. So aniline on reaction with bromine water gives formation of 2,4,6-tribromoaniline. Here in this reaction, all the ortho and the para positions are so active that any electrophile like bromonium ion will get attached over these positions to give this product. The next reaction is the sulfonation reaction. Dear students, the sulfonation reaction is carried out by reacting aniline with concentrated sulfuric acid. Now aniline is basic in nature and sulfuric acid is acid. So there is an acid-base reaction to form the corresponding salt, which is called as anilinium hydrogen sulfate, which if heated at 180 to 200 degrees centigrade gives formation of para-aminobenzene sulfonic acid, which is also called as sulfanilic acid. So here there is the migration of the sulfonyl group from the amino to the para position. The next is a very important part, that is preparation of sulfanilamide. Here aniline is reacted with acetic anhydride in presence of sodium acetate to form corresponding acetanilide. Acetanilide on reaction with chlorosulfonic acid gives formation of para-acetamidobenzene sulfonyl chloride. This on treatment with ammonia gives the corresponding amide, which is called as para-acetamidobenzene sulfonamide. This para-acetamidobenzene sulfonamide on hydrolysis loses acetic acid molecule to give formation of para-aminobenzene sulfonamide, which is commonly called as sulfanilamide. Dear student, this moiety is important in the manufacture of various sulfur drugs. So that is all about the reactions of the amines. Thanks for watching this video. Please like, share and subscribe. Thank you.